This video covers the least squares line, and the least squares line is an equation that fits a set of data in a linear pattern. So hopefully you watched a video that helped you understand what that least squares regression line was and what it accomplishes. I'm going to be using technology, and you'll see the website over to the left, and here's the link for it. In the example that I'll work with, the example is about 30-year fixed rate mortgages. So let me scroll this down so there's a little bit more of the screen for this problem. Example, the data is an annual average of 30-year fixed rate mortgages, and we're going to let x equals 0 to represent the year 2000. Over on the right, I have a table of interest rates. In the year 2013, the average interest rate was 3.98 for a fixed rate loan. And for 2014, it was 4.17. And then you can see last year in 2018 was 4.25. What I'm going to do is I'm going to come over to the Correlation and Regression Calculator website, and I tend to prefer to use the data grid to input my data. So my first ordered pair is going to be for the year 2013, but I will write the x as just 13. And then below that, I have 3.98. The year 2014 will be written as 14 and 4.17. So I'll get all this entered and then move on to the next piece. Next piece I'm going to do is click the button, find the equation of the regression line, and I will hit compute. This particular website does take a while to process the data, but you can see here in the box that is the table that I entered, and right below that is the equation. Let's take a look at the graph for this equation. Here is the scatter plot. Scatter plot has on the x-axis the years and on the vertical axis the mortgage rates. You'll notice that that doesn't start at 0, it starts down at 3.5 though. And then we have our blue points, which is representing all of our data. If I scroll over to the right, you'll see another data point there. This black line is the graphed line for our line of regression, and so that's the best fitting line for our 6 data points. Let's go and interpret what this equation says. So the equation had said y equals 0.023x plus 3.642. The y-intercept at the end is telling us what the mortgage rate would be for a 30-year fixed mortgage in the year 2000, because remember we had let x equal 0 for the year 2000. Part B says estimate the 30-year fixed rate for the year 2019. So the 2019 would have an x value of just 19. I'm going to substitute this x value of 19 into the linear equation. So substituting 19 in and multiplying it with the slope, then adding the y-intercept value, I arrive at 4.079. That means the predicted mortgage rate for the year 2019 on average will be 4.079 or about 4.08. I do recommend utilizing resources such as the website to the left for calculating and determining the linear regression line. I do not want students determining that by hand, even though MathXL or programs such as that will show you how to calculate it by hand.